Impoundment space for coal preparation plant refuse is becoming increasingly scarce. Not only are permits getting harder to obtain, but they are also more expensive to defend, and therefore maximizing the utilization of existing impoundments just makes sense. Many operators have already adopted smaller footprint methods such as slurry cells that allow the capture of low carbon waste fines capped with coarse waste and alternating lift layers. However, rapid turnover requires that water breaks free and cell surfaces dewater and solidify quickly. The cells need to be solid enough to allow access by the heavy machinery needed to move and spread subsequent alternating layers. This entire process must be completed quickly enough to prevent the domino effect of process interruption at the coal preparation plant. Alternative options for waste fines disposal employ various mechanical methods to achieve solids dewatering and densification for thickener tailings. Typically, the weapon of choice has been a twin belt filter press or vacuum disc filter, but a relatively small group has opted for what are usually called paste thickeners. Regardless of the chosen mechanical approach, the goal is the same: to improve environmental stewardship while maximizing the business benefit and minimizing negative operational and process impact. To achieve this goal, tailings volume must be minimized, allowing for operations to maintain the smallest possible impoundment space, improve impoundment stability, and increase turnover in the impoundment space. This is realized by clean and rapid tailings dewatering, which creates high-density, stackable solids for the impoundment fill zone. As a result, operators maximize their operating time and production potential, while providing greater environmental sustainability. Nalco can customize an Orebind program to help operators accomplish key impoundment management goals. The resulting program uses the force and volume of a locally pressurized water supply and Nalco's proprietary Pareto mixing technology to rapidly activate specially selected chemicals. The result is dilute and readily dispersible solutions that can quickly dewater and significantly increase the density of high solids refuse slurries. Once an optimized solution is chosen, it is strategically injected into thickened underflow solids on their way to the slurry cell or impoundment fill zone. Clean water breaks free almost instantly, rather than going through the normal, time-consuming evaporation process. The faster the dewatering and drying cycle, the sooner the access with heavy equipment or addition of coarse refuse to further stabilize the impoundment area. 40% of tailings are typically recovered as clean water within 1 minute and with a specific gravity underflow discharge of 1.20. A plant pumping 500 gallons per minute of underflow tailings could release and return approximately 200 gallons per minute of clear, recyclable processed water. This liberated water can be decanted back to the plant and used for chemical solution makeup, plant processed water, or simply discharged. Note the result just a few days after treatment. You can walk on it. All of these benefits work in unison to permit a virtually continuous use of the impoundment area. Additionally, the discharge location and treatment system for the Orebind treated solids can be easily moved around either within the same cell or an adjacent deposition area. By designing multiple discharge ports or periodically moving the discharge location, the treated solids can be opportunistically distributed to provide maximum utilization of the limited impoundment space. If you are looking to extend the life of your slurry cell or impoundment, as well as save production time, a customized Orebind program is an option worth considering. While it yields similar results to a paste thickener program, the Orebind program does not require the extraordinary capital cost of a paste thickener, which is approximately $2 million to purchase, install, and maintain. For a custom Orebind program, the equipment can cost less than $20,000, and the chemical costs are often similar to those for a twin belt press. Before you make a decision, consider contacting your Nalco sales engineer for more details and to schedule lab tests of your specific slurry in our Blacksburg, Virginia coal laboratory. More specific information on the benefits, features, and requirements of an Orebind program for your operation is available from your Nalco sales engineer.